already begun. Maybe we can get more people joining. Yeah, I'm doing that.
Awesome. So let me just start with the recap. And if anything happens, whether my screen freezes or anything, just let me know, and I'll make a point of fixing it. Dickens, maybe you can unmute. There's some background noise coming from your side.
Oh, sorry.
Yeah. Thanks. So this will be, if everything goes well, this will be the last class that we have on Java collections. It's very sad. I wish we could. There's more to. Of course, there's more to Java collections, but in terms of the way we've structured the curriculum, this should be the session where we cover the last data structure. We've covered arrays. We've looked at the collection interface. We've covered lists. Sets. We covered sets last time. So today we'll be looking at the last critical data structure, which is maps, and it will form the end of our exploration of Java collections. And once we are done, my hope is there'll be somebody else who will come in to cover algorithm optimization. They'll cover things like space efficiency, time efficiency, I think, and big O notation. So it will be a session on teaching you how to write faster and more optimized algorithms. So that should be what comes next. But today I endeavor to conclude this journey of ours within the Java Collections framework by looking at the map interface and some concrete implementations of map. And that will be the thing that we will be checking out. If you have any questions, as usual, feel free to interrupt, drop a message, or just unmute, and I'll be more than happy to look into that so that we can learn even more together. So let's do a small recap of what we've covered so far. So we learned about a few data structures. So the key data structures within Java that we've been able to look at is list. We've also looked at sets. And with lists, we're able to look at a concrete implementation, which is ArrayList. Just a second. So we're able to look at ArrayList. And beyond ArrayList, we're also able to check out another concrete implementation of list, which is a linked list. And before we even looked at these data structures, we were able to look at the collection interface, this collection interface, and we're able to use it to implement our own custom collection. And we learned about the standard functions that are supported in the collection interface, which was really nice. And knowing that you can create your own custom data structure, implement the collection interface, and have it qualify as a collection, which means it plays really well with existing collection APIs that are available in the Java Collections framework. That was a really good exploration that we got there. With the sets, we looked at sets, and we were able to use the concrete implementation HashSet. But most importantly, we learned how to do set operations. So we were able to look at set operations, and the operations we were able to look at was union, intersection, and difference, or sometimes referred to as symmetric difference. So today we will conclude this journey with maps. But first, I want us to do a small recap of the capabilities that we can do with list and set data structure. So one fundamental thing that you need to always remember when working with these data structures is how to create them, how to add elements to the data structure, and how to iterate over the elements in the data structure, which is the most common operation you'll be doing. So with a list, you can create a list like so. And you can, so if this is a list of numbers, you can have a list of numbers, and you can create the list by referring to its concrete implementation, which is ArrayList. You can add elements to the list, like one, you can add two here. And once you've added the elements, you can iterate over the elements of the list, either using an iterator. So you can have a custom iterator by calling numbers.iterator. And you can use this iterator to iterate over all the elements in the list. So here we can do io.println, and we'll be able to print every number. So you can say n is equal to iterator.next, and that will retrieve the next element and print it. So if you run it, you'll see that we're able to print the elements in the list. You can also iterate through a list using an internal for loop, and the way you do that is you use for integer in, so you can call it n in numbers, and here you can we can go ahead and print the value the same way. So you can say n value is n, and like that we're able to iterate over the number. So that's another way you can iterate. The other way you can iterate is using forEach. So you can call forEach numbers.forEach and have n here representing the number, and you can print the number that you get. So if we run that, you'll see we have 1 and 2. So that's how you can create a list, and you can iterate over the list. Another thing we learned about the list, which is important, is you can retrieve element by index. So you can say var first number fn is equals to numbers dot get and pass in the index, and this will give you the first number. So if we print this, we'll see that first number is will be fn, and if we print fn, we'll see that fn is 1, which is the first number. So you can retrieve elements by index. So this is some of the operations we learned that you could do with lists. The other interesting thing we learned about lists is you can create unmodifiable lists using functions that were added in Java 9. So this is a Java 9 specific feature. And the way you do that is, instead of using ArrayList here, we can go ahead and use List.of, and we can pass the values directly. And now when we run the operations that we have there, we'll see that we're able to get the first number, and the numbers in the list is 1 and 2. The important thing we learned about this unmodifiable list is that once you create an unmodifiable list, you cannot add elements to it. And if you try to attempt to add elements to it, let's say we want to add 3, we will get an unsupported operation exception. So your program will fail with that error, because it's an unmodifiable list, which means you're not allowed to add elements to it. Another way you can initialize, so let me stress another thing on this unmodifiable list, and this is something that I was not able to demonstrate last time. I hope I'll be able to demonstrate it this time. The reason, the thing is, initially when this feature was added to Java 9, this was referred to as immutable collections. Immutable collections. And the thought at the time was, because you're not able to change its size, you're not able to add elements to it, you can only retrieve elements, you can only iterate over the existing elements, it qualifies as immutable. But what was discovered was, if you created a view, of an unmodifiable list, so a view of an unmodifiable list, you could be able to mutate that view. So what I'm referring to is, we can create a list here of integers, And let's say this is the original list, call it all list. And this original list is a modifiable list because I've initialized it with new array list. And I can add elements to this list. I can add, perhaps let me add 4 and 5 to this list. Add them in separate lines for some consistency. So I can add to all list 5 and 4 and 5, and we can create another list here of integers, and let's call this view of all list. And you can call this convenient function in collections dot unmodifiable list, and this allows you to take a modifiable list like this all list and create an unmodifiable list of this all list. So you can pass in a list here. And if we look at the documentation for it, we'll see that the documentation says this returns unmodifiable view of the specified list, query operations on the returned list, read through to the specified list, and the attempts to modify the returned list, whether direct or via its iterator, results to unsupported operation. So this unmodifiable list behaves the same way regular List.of behaves. So this is the same as this, except this allows you to pass in an existing list. And in this view of list, if we attempt to add another value to it, say 6, and let me just get rid of some of these so that we're able to see that in action. So if you attempt to add to that view of list, we'll see that we get an unsupported operation exception. But if we add to this all list, we're able to add values like you see here, but you're not able to add values to the unmodifiable list that we created from all list. Now, the interesting question comes in is, since all list is unmodifiable and this view of list is a view of all list, what happens when we change all list? So if we have, we have 4, 5, and then we create view of list. So view of list should have 4, 5 at line 12. And then line 13, later on, we add another element. Will this element be exclusively added to all list, or will it also be available in view of list? So let's print both of them and see. So this will be all list, the original list, our OG list, all list, and the other one will be view. I'll just call it view list, and it will be a view of list. But let me rename it to view list. And now if we run this, let's see how those lists appear. So we'll see the original list has elements 4, 5, 6, but this unmodifiable view list has elements 4, 5, 6. So it means we're able to mutate view list despite it being an unmodifiable list. So that's the important thing you always need to remember, is that there is a very deliberate reason why these unmodifiable collections are called unmodifiable and not referred to as immutable, because you can change them indirectly. So if they're a view of another collection, like this unmodifiable collection is a view of this collection, you can still mutate it. So we could even add another value, like we could add 7, and if we executed that, we'll see that now our all list has 4, 5, 6, 7, and view of list also has 4, 5, 6, 7. So you can modify it indirectly by modifying the original list. So that's something important to remember. So this is how you might end up being able to mutate an unmodifiable list. So that's why they're not called immutable lists. So that's important. Beyond that, if anybody has a question regarding this, feel free to ask. But beyond that, another thing is we were able to, so we looked at lists, array lists, and we learned how to initialize the list. The other thing I probably didn't share about initializing a list is there's actually a third way of initializing a list. So I'll try to retain some of this code here for future consumption. So there's a third way of initializing a list. And the way you do that is you can say list of integers, my list. There's this convenience function from arrays, and you can do arrays.asList, and you can pass in the value. So in terms of syntax, this behaves the same way as list of integer end list is equals to List.of, and you can also do the same thing here. 2, 3. So you can initialize a list using this convenience function. Instead of calling add multiple times, you can do List.of, or you can do arrays.list. So what is the difference between these two? The difference is this creates an unmodifiable list, but this creates a modifiable list. Although the syntax looks a bit similar, in fact, they look somewhat the same. This will give you an unmodifiable list, but this will give you a regular list, as if you used new array list. So it's just a convenience syntax. When you want to have a modifiable list, but you don't want to call add function multiple times. You just want to initialize it once and be able to use it without any trouble. So that's what that is for. And we can actually see this in action. If we try to add a value to end list, which is the unmodifiable list, just like we saw, if we try to run that, we'll see that at runtime, we get unsupported operation exception. So that fails. But if we add an element to my list, which is the one we created with arrays.list, we'll see that we are able to, let's see, my list, arrays.asList. Okay, looks like we can't modify this as well. Arrays.asList. So, okay, so this returns a fixed size list backed by the specified array. So this also behaves somewhat the same as List.of. So we cannot change the size. I was under the impression that you'd be able to change the size if you initialized it like this. But also, I guess I was wrong about that as well. So you're not able to modify this. So it kind of behaves the same way as List.of. Unless I'm using it wrongly. Let's see what the documentation says. Okay, so this the list returned by this method is modifiable. To create a modifiable list, use a list. Yeah, I was expecting this to be modifiable. I think it's modifiable in terms of you can change the value at a specific element. Let's see. My list.set at index 0. Let's change. So index 0 has 1. We can change it to 5. And let's see if that operation is allowed. So it seems that operation is allowed. Let me print the two so that you can see them side by side. So this is our unmodifiable list. Unmodifiable list, which is end list. And we have the modifiable list. So now if we print out the result of those two, we'll see unmodifiable list has 1, 2, 3. Modifiable list now has 5, 2, 3. I guess the question now is, can we call set on end list and change the value at that index, just like we did with my list? Because it seems the difference is that you cannot change the size, but you can change the elements. But when it comes to unmodifiable, if that operation is also illegal, yeah, so the operation of changing the value of an element is illegal when it comes to the unmodifiable list. But with arrays.asList, it's like half modifiable. it's like halfway modifiable. By halfway modifiable, I mean we are able to change the values. So you can change the values, but you cannot change the size. So you can't change the size of the list. You can't change size. Yeah. So that's the difference between these two. So this is modifiable as long as you don't change the size, but this is unmodifiable in that you can't change the size and also you cannot change the values of the elements. So you can call set on List.of and change the value at a specific index, but with List.of you're not able to even change the value that already exists. Different to add, but with the arrays.list you also can't change the size, so we still can't call add and add a value. So this would still be illegal. This would still give you unsupported operation exception. So you can see how it can get a bit tricky, but it's important to remember that there's a difference between list.of and arrays.asList. So that is as far as lists. The other thing we looked at was sets, and with sets we learned about how to initialize a set. So it follows the same syntax. So you can have a set of let's have a set of strings, and this is a set of names. Let's use fruits this time, and the way you initialize it, you use HashSet, and with HashSet you can call add to add elements to it. So you can have apple, you can have another fruit like orange. And the difference between a set and a list is that a set does not allow duplication. So all the values are unique. So it's unique values. If you try to add a duplicate, the set does self-correction. So that you don't end up with duplicates. And if we print this set, in terms of iteration, you can also use the same iteration methods that we used in list. So you can do a forEach on this set, and F for fruit, you can go ahead and print the fruit there. So you can also use an internal for loop, enhanced for loop with for. So here is a string, and that's a fruit. In fruits, we're able to see that we're able to print the fruit like so. So this and this will achieve the same effect. So you can do the same iteration operations as you would with a list. So if we run that, we'll see that we get orange and we get apple. So if we attempt to add duplicates to a list, like if we duplicate apple, so we add apple, and we add orange twice. If we try to do that, we'll see that the set itself self-corrects, and now we only have orange and apple. So the duplicates are removed. So that's the most important thing when it comes to sets. And the other thing is, because of this uniqueness, you can use it to perform set operations, and we covered that in detail in the previous session. So I won't go into that per se. So this is what you can do with the set. Then the other data structure that we'll be looking at today will be maps. So any questions on the data structures I've recapped, the list and the set, array list? Of course, we looked at linked list. If you have any questions regarding that, let me know. Okay, if there are no questions, let me go to maps. All this source code will be available on this recap. Looks like I commented out everything. Let me uncomment, and I'll share the GitHub repository, of course, after this, and you guys can check it out. So all the source code is available there. So let's look at maps. So maps class. So I'll just create a compact source file here for us to explore this part. And when it comes to maps, let's explore a situation that would warrant using a map. So, and we're going to have an example that we all deal with every day, and this will be user accounts. And user accounts specifically when it comes to building a login screen. So we're going to build a login screen, of course, without UI, or at least try and simulate a login screen. So for every software systems, there's usually users, and with the users usually have certain characteristics. They'll have an ID, they'll have a name, they'll have an email, they'll have a password. This is usually the most common thing. So we can create our own user using Java records. We can have a user, and that user will have an ID. We can use long for that ID. They can have a name, can use string, they'll have an email address, I'll use string as well, and they can have a password. And this would qualify as a user. Questions? So Alex is asking, why are lists preferred over sets when performing retrieval operations? For example, when trying to retrieve user details, we write public list set list user instead of public set user. Hope my question is clear. So I think lists are preferred, especially in that example that you provided. They're used because of convenience, and also because people are not familiar with how much extra performance you get when you use sets. And also, the other thing that might encourage use of lists is in many cases, we don't care about duplication. So when you don't care about having users with the same name, you might not worry too much about duplication. So a list will just work fine for you. So sets become very specific tools when you want uniqueness in your data structure. Otherwise, if you don't want uniqueness and then you end up using a set, it might actually lead to undefined behavior in your program. Because as you saw in the examples that we did, if you use a set and you accidentally add duplicates, what will happen is the set will just ignore the values that you add. After that, you won't even get like a runtime error. So I think that's one reason people prefer it. It's very targeted. It's used for a very specific thing. Kennedy is saying also they are ordered and set does not care about order. Yes, by the way, yeah, that's very important. When we were covering lists, we talked about insertion order is maintained. Sets don't care about order. So if you want the order with which your elements are arranged to be predictable always in your program, a list becomes super convenient for that. Sets don't care about order, and then the data structure we're going to look at next, which is maps, also don't care about order. So for example, although we are going to talk about it, when a map rearranges its something called hash function, if it creates a new hash code, it doesn't put order into account. And that might become a deal breaker for some people. So yeah. Alex, does that answer your question? And Kennedy, if you want to add to this, okay. Kennedy, is there something you want to add to that question? Okay, good. Yeah, so let's look at maps. So we have our user here, and the user has the properties that you'd normally have for a user. And what we want is we can have functions. So we can have a function here that should I use functions? Let's do it plainly. So we can create a list of users. These are our users, and now that we learned about List.of, let's use List.of, and we know this is unmodifiable. So if we get to a point where we need to modify users, we'll have to change it to something else. And now we can create a user, and the user will have an ID, one, that's our first user, and our first user here is Alex. Their email is alex at gmail.com, and their password is pass, a very strong password, pass123. And we can have, let's have 3 users. So there's Alex, there's Kennedy, there's Joe, and Ken at Gmail, and here we have Joe at Gmail. They don't share a password, so let's say this is a different password, and this is 1, 2, 3, 4, something, and that's their password. So here we have a list of users. Now, if we want to, so let's imagine our list of users is in a database, and we want to log in a user. So we want to log in a user, and when a user wants to, okay, let's begin with a simple example. Let's begin with the retrieval. So we want to find a user, and we can have a function here that returns a user. So the public function, and it returns a user, get user, and we obtain this user based on their name, for example, or let's use email address. And what this does, it will go through the list of users that we have. So we can also pass it the list of users, and this is our database. So it will go through the database of users that we have and check for a user based on their email. So one way you can implement this is you can go through all the users. So for every user in, for every user here in our database, we can go through the user, check their name, their email. We're using email here. So you can check the email and check that it's equals to, so equals, you can do equals or equals, ignore case, equals to the email that we are checking with. And if the email matches, we can break this loop. We can break the loop, and that means we will have found our user. So we can say user found user is equals to null before we find them. And if we find them, we can say found, that is found, found equals to that user. And of course, if we don't find a user, we'll just return null. So this will be our function that helps us find a user. So if we come here and call our get user function, so let's say somebody is trying to log in. Let's say Alex is trying to log in, and Alex's email address is alex@gmail.com. So if we do get user and we pass in Alex's email, which is alex@gmail.com, and we pass in the database of our database of users, which is that users, we should be able to get the user here. So this should give us Alex or null. So if it doesn't find Alex, it will give us null. And now we can print whichever user was found. So you can do a print line, matching user is Alex or null. And if we run that, we should see that we're able to find Alex, so user with ID 1, alex@gmail.com, and their password. So this works, but this is very inefficient because for every time we want to find Alex, so if Alex was, let's imagine this was a database with 1 million rows. So let's assume that we have 1 million other users before we reach Alex in this database. And then Alex is like at the bottom there. Using this ID, this should be different. So we have like 1 million other users, and Alex is number 1 million and something. So let's say this is if this was an incremental DB, let's assume this is Alex here, and this is somebody else, and this is somebody else. So it's a lot of people before you get to Alex. So this can be very inefficient. And to have a more efficient method, we'd want a behavior like we would get with arrays. Remember, with arrays and sometimes with the lists, you can access elements based on their index. So we can say we want Alex at index at position that. Let's say this was position 2. Let's assume the ID is the position. So we can say we want Alex at position 2. And what that will do is when we're retrieving Alex, our algorithm will go directly to index 2 and retrieve the value, which is Alex. Let me just demonstrate that. If we bring this back to, don't need to use L there. If we bring this back to the way it is, and let's say we know where Alex is, we can do users.get at index 0, where Alex is, and this will give us Alex. So Alex is here. And if we print this, I'll just print Alex. So if we print that, we should be able to see Alex. Let me comment out this other one. So if we print that, we'll see that we're able to obtain Alex. So the difference is this is way more efficient because we're going directly to the index and retrieving Alex. We don't have to loop through every element in that list for us to retrieve Alex, which is what we are doing here. So if Alex is at the bottom, this loop will run 5 million times before it gets to Alex. If Alex is at index 500, it will go 499 times before it gets to Alex. Of course, if we know the index where Alex is, we can just call get passing the index and we'll be able to retrieve Alex, and we don't need to loop through. But how do you achieve that effect with a complex collection like this? Because what we know is, as users are being added to the database, we will not always know where everybody is. So we need another way of quickly identifying a value in that data structure. So the way that Java solves that problem is within your data structure, you can have a key and a value. So if you remember the example where I used get function, so here I passed 0. So, and by passing 0, I was able to get Alex. So in this example, that's Alex. So in this example, Alex is the value, and 0 here is the key. So 0 is the key. So Alex is the value that we retrieve, 0 is the key. So since we have the key, which is 0, we can just insert it into the DAO, which is our database, and get Alex back without having to do this inefficient looping. So that's how we're able to bring some efficiency to retrieving data from a large collection. So to achieve this effect, we use a data structure called a map. And a map basically represents a key and a value. And at any one time, one key always points to one value. So you can't have one key pointing to multiple values, except for some advanced cases that we'll look at. But fundamentally, a key points to one value. If you add a key that was already pointing to a different value, what will happen is that key will just change and point to the new value. So at any one time, 0 will always point to Alex. That is our value. So how do we achieve this in Java? So we have this map interface that essentially refers to the map. And the map works with a key and a value, like I mentioned. And when we initialize a map, let's say this was a map of users map. Let's say this is users map. So the way you work with the map is the same way we work with lists and sets. So remember, with the set, we're able to create a set of a particular type, and this would be our set, and we'll be able to initialize it with a concrete type like hash set. So with the map also, you initialize it with a concrete type, which in this case is a hash map. So there's additional concrete types that you can use, concrete implementations of map that you can use, but the most common one is a hash map. So this is how you create a hash map. And the main thing that you need to remember is with maps, you have a key and you have a value. So the key is what you'll use to retrieve the element, just like we do with indexing in arrays. And the reason why there's a lot of similarity between this and arrays is all data structures, I think almost all data structures, are built on the foundation of arrays. So if you look into any data structure, if you look into a list, if you look into a set, if you look into a map, what you'll find hidden inside there is an array with some custom capability. So that's why there's a lot of similarity into in like how arrays behave. So let's see. So let's try and solve this problem of looping through a lot of users to obtain Alex by using a map. So we can have a map, and we need to decide what will be the key that we'll use to retrieve our values. So what is unique with these values that is predictably unique, that we know will never duplicate, or at least we'll try and ensure it doesn't duplicate. So the main thing that's unique with these users is their email address. You'll notice if you create an account in most systems, they won't let you create an account for an email that already exists. So they'll try to keep the email unique. And the advantage of keeping that email address unique is that you can use that email as a key to quickly retrieve the value. So we can have our email here as the key. And since the email is a string, our map will have a key of type string. So it will be a key of type string, and it can have a value of type user. So it will be user. Remember, this is utilizing generics, so the key and the value can be any type that you want to use. And this will allow us to create a users map that's different from this. And in our users map now, we can add the users. So you can do users map. So initially we're using add to add values, but with maps you use put, and put function allows you to pass in two things, key and value. So you can pass in a key and a value. So the key here, for example, will be alex@gmail.com. So you can have alex at gmail.com. And the value will be this object, which represents Alex. So let me just highlight it. So that will be our value here. So our map has two things. It has the email address and it has the actual object, which is the user. And we can create a map that represents our users database, like so. And we can have ken@gmail here. We can have joe@gmail. And this will be their keys. And of course, the values will be their actual user accounts. So this is ken and ken@gmail. And this is joe and joe@gmail.com. Of course, they have different passwords. I don't want them having the same password. So this will be a representation of our map. And now, first of all, let's see if we can print this map. So let's try and print it the regular way, users map. And you can just annotate it, concat it there, and let's see what happens. So if we print it, we'll see that we have Ken. So we have this data structure behaves in interesting ways in that we have the email address, which is the key, and then we have the object. So if we move forward, you see we have the email address, which is our key, and we have the object that email address is pointing to, and so on. So for every object that is stored in the data structure, there's a key and there's a value. So you have key value pairs. So that is the important thing to remember about maps. And now if we want to retrieve Alex, you can just do users map dot get, and we can pass alex at gmail, because that is the key, at gmail.com, and this will give us Alex. So var Alex is equals to that, and we can print it io.println, and we can print Alex. So just by passing the email address, we can already obtain the user. So if we run it, we'll see we get user. So now we can refactor our get user function, and now when it retrieves a database, instead of receiving a list here, it can have a map, and the map has, of course, the key and the value. The key here is the email address, the value is the actual user. And instead of doing this iteration, what we can do is instead we can reduce this down to database.get email, and this will help us fetch any user just by passing their email. So now we can do the same thing for any user. So we can call var let's say we want to obtain user 1. You can do get user, which is our function. We can pass in the key for the email address, like joe@gmail.com, and we can pass in our user's map. So it will get this will get them. It will get the database, which right now is key value pairs, and it will get the email address that we are searching for. And if it finds it, it will be able to print it. So if we do print line here, and we say user 1 and run it, just like we did with the Ken example, we'll see that we have Joe at gmail.com and their password. So this is how you work with maps. So you store values as key value pairs, and then you can retrieve values by their key. So what happens if we pass in a key that doesn't exist? So let's say var user2 is equals to get user, and we pass in maybe jane@gmail.com, which doesn't exist in our database of users. So if we try and print that, let's see what we get. So if we try to retrieve a value that doesn't exist on the map, you get a null. So this is important to note, because if you are retrieving values from a map and you don't have proper checks, this might hit you with a null pointer exception if you try to use user. So like if we try to do user2 dot email address to like retrieve their email address, this will give us a null pointer exception. So it's important to remember that if you try to retrieve value from a map and you pass in a key that doesn't exist on the map, you'll get a null pointer. So you need to ensure that the key that you are passing in is the correct key. There is convenience functions in Java that make these less dangerous, and one of the functions is this function called get or default. And what get or default does is you can say, if you find the value, return actual value. So if it finds something, it will return actual value. But if it doesn't find a value, instead of returning null, it will return a default value, which is safer than returning null. So let's try and use that get default in action. So we can, within our function here, instead of calling get, we can say get or default, and we pass in the key, but also we pass in a default value. So we can return a new user, and this user doesn't have any characteristic, and we can modify our record here to allow us to have a constructor that initializes a user without necessarily passing any values. So by using default values. So the ID we can do -1, with the name we can do blank, with the email we can do blank, and with the password we can do blank. So this allows us to pass a user that is essentially empty. So instead of returning null, this does get or default. So now if we do the dangerous call that we did here by trying to retrieve jane@gmail.com, although jane@gmail.com doesn't exist in our map, and if we run it, instead of getting a null, we'll see that we get this default user. So that's one way you can use this safely. Of course, there's the use of optional, but optional will be covered when we do functional programming in future. So there's another API called optional that you can use to avoid running into that null pointer exception. So this is how we do maps. Maybe the other fundamental operation that might want to do with maps is iteration. And iteration is very important. So let's look at iteration. So what if we just want to loop through our users? So we are not doing anything fancy. We just want to iterate over our users and print them like we did with the list and the sets. So the way we would do this is within maps, there's two data structures that are formed that are utilizing a data structure that we covered earlier. So maps wraps a data structure called a set, and it uses sets in two ways. So there's a set of entries and there's a set of keys. I think with keys, keys only is why we use sets. So because the keys have to be unique, we use the set data structure. So set, you can have a set of keys because all these keys have to be unique. So it only makes sense to use keys. So you can get this. We can have the values represented as a list. So you can have a list of values. And what this means is we can retrieve the keys, all the keys in this set without their respective values. We do that by calling users map.keyset, and this will give you all the keys in a set. So if you look at the function, it returns a set of keys, and the documentation says returns a set view of the keys contained in this map. The set is backed by a map, so changes to the map are reflected in the set. So it does the view behavior that we saw with the List.of with the unmodifiable list. But the main thing you need to remember is that this gives you all the keys. So let's try and print that. So we know we are getting a set. Let's just confirm that. So we are getting a set and our key is a string. So it will be a set of string. And this is all the keys. So this is keys, and we can print those keys. So if we print that, we should see all the keys. So this is all the email addresses. So you can have them as a set. And because the keys are unique, like I said, it means that you are able to put them in a set. There's this other concept in maps called entry. And entry is an object that wraps key and value pairs. So this entry wraps one key and its respective value. And you can obtain it by referring to users map dot entry, and this will give you, so this will give you the entry set, and the entry set will have just like you can see, it will have a set that has an entry mapped inside, but this entry is a key and a value. So it's like it's going through each value in the map and taking the key and the value and putting them in a dedicated collection. So it's wrapping them and then returning a collection that maps all the keys and values that you have in your map. And if we try and see this, so this we try and print it. So this is the entry set. So this is the key set, and this is the entry set. So this key set has a set of keys. Entry set has a set that contains all the keys and values wrapped together. So if we print this entry set, I don't know if we'll be able to print it directly, but let's just try and print it. It might not give us anything. So if you print that entry set, we'll see it has Ken at Gmail and the respective value in its own data structure. We'll have Joe at Gmail and the respective value, and we'll have all the values that we have in the data structure. But the most important thing that you need to, the reason why I'm bringing this up is you have to use this for iterating through a map, because a map is not like a a list or a set where you have one value at every row or at every index. With the maps, at every index you have two values. You have the key and you have the value. So you have two things that are represented at every index. So when you want to iterate through a map, you utilize this entry set idea, and the way you do that is you will have a map dot entry. So this will represent an entry, and this entry is a key value pair, and it just uses the same key value pairs that we key value pair types that we used in our while creating our map here, string and user. And here I'm writing a regular enhanced for loop that we saw earlier, and this represents an entry and represents all the entries in this entry set. So you will not refer to the map this time, we'll refer to the map's entry set. So you can say entry set there, and that will represent all the entries. You see I'm referring to entry, all the entries in the maps entry set. And here, since each entry has the key and the value, I can get the key, which is the email, by calling entry.getKey, and we can obtain the value, which we do by calling entry.getValue. So this entry wraps a key and a value, which means we can use it to retrieve the respective key and the respective value, and we can print each of those here. So we can say email, which is the key, and we can have printed separately the value, which is the user in this case. So value dot maybe perhaps you can just have the name. So this will give us the email and the name. But to demonstrate this properly, let me just print the whole value. So this is a user. User is our value, and let's just try and print the whole thing. So if we run that, we should see that we get email Ken at Gmail, then we have user Ken. So here I was obtaining the name alone, but you need to remember that this is the whole user. So you'll see we have Ken at Gmail, and then at user we have user with ID 2, name Ken, Ken at gmail.com. Same with Joe, we're able to see that those are their values. So this is one way you can iterate through a map. You can obtain the entry set, which you can also do this in line. You can just say users map dot entry set. So that will eliminate the need for doing all of this. So you can have users map dot entry set, and then you can iterate through the values. And if you run this, you'll get the same effect. So here you see we have the key, which is our email, and the respective value, and that is repeated for all the values in the map. So that's how you loop through a map. There are more enhanced ways of looping through the map. You can also use Java 8's feature, which is the forEach. And the forEach is different from the list forEach. When we're doing forEach with the list, what we would do is we would have the element that we're iterating over as the input to that, and then we can do some operation with that. Yeah. But when it comes to maps, you have two arguments. You have the key and the value. Again, key and value being prominent here, and you can use that key and value to do whatever you want. So let's say we pass in the key. We know our key is the email. In fact, let me just use key and value here. So this is key and this is value, and we can go ahead and print. So we can print the key and we can print the value. So let me use some concatenation here to help us. So the key is the email address, and we can include the value. And if we run this, we'll get the same effect with the internal iteration. In fact, let me comment out this, but it's a bit more clear. And if we run it, so we'll see that we get the same effect. So we have the key, which is ken@gmail.com, and we have the value, which is user2, name, key, Ken, and they're like that. Interesting thing you should note here is also the iteration order is not, the insertion order is not preserved, like we saw with lists. So you'll see here we are getting Ken first instead of Alex first. So this is something important to remember when you're working with maps. The insertion order is not preserved. In fact, order is not predictable. So the map is free to shuffle the order as it wants. I just noticed I was using the same ID here. Let's see if we run it with the IDs changed. So you'll see we're getting 2, 3, 1. Okay, so in this case it has been a bit consistent, but the order is not preserved. So you can get the values in different orders. So that's how you iterate over map. You can also use an iterator. So you can obtain an iterator by calling users map dot entry set dot iterator, and that will give us an iterator. And this iterator, we can use it the same way we were using the other iterators, checking has next, and then we can do iterator dot next, and you'll see the iterator dot next will give us an entry. So this will give us an entry, and that entry has, of course, string, the key, and the value here being string and user, and this is our entry. So the entry into the map. Get an import for that. So yeah, so this would give us an entry, and you can do what you want with the entry. So for now, just like we've been doing, we can just print that. We know this is the email is the key, so we can call get key, and we know that we can get the actual value by calling entry dot get value. That would give us the value. So if I was to comment this out and run it, you see that we're able to get the same print. So you can obtain an iterator by calling entry set.iterator, and that will give you an iterator that goes through all the entries, and you can use the classic iterator that we've been using. You can use Java 8 forEach, and you can use an internal for loop like so. So whichever method works for you, you can use it to iterate over the map. Questions or comments? Maybe something I missed. Okay, so as I wait for questions, there's some other functions on maps that we can look at. So if you guys remember when we were looking at the collection interface, we saw that we have size that should be available in every collection. We have contains, we have is empty, and the others. So we have some functions that we can access. So we can use most of this. So you can call users map and obtain the size, and this will give you the size of the elements. So in this case, our users map has 1, 2, 3 values. So if you print this, we expect to see 3. So you can say map size, and I concatenate that. We should see that we get the value. So we can see the size is 3. We can check whether it's empty by doing essentially the same thing, and you can do map is empty. Remember, this is a collection, so all these collection functions should be available unless they are explicitly unsupported, in that if you try to use them, you get unsupported operation exception. But if they are supported, then you get the same behavior that you get from every collection. So it's empty is false. So that's working correctly. And the interesting one here is contains. If you guys remember, contains allows you to pass in an object. So here you can pass in an object, and the algorithm will check whether that object is contained in the wrapped collection, in the collection itself. So with maps, this contains function has some extra capability, because now we cannot just check contains by object. We can do contains by key. So you can call users map dot contains key, We can also do contains by value. So you can call users map dot contains value, and you can check whether, so in fact, let's make this a bit interesting. So let's say you want to register a user, and before we register a user, we want to check whether the user email is already taken. So is email already taken? So you can have a function that checks whether the email is already taken, and all it does, it receives the email of the user attempting to register, and of course it receives, just like the other function, it receives these key value pairs of the users that we have. Call that DB shorthand this time. And we can check whether that email is contained by simply calling our DB, which is our map. In fact, let me just call it a map here for the purpose of following along. So we can do map.contains key, because we know the email address is our key, and we can pass in the email. And this will give us true if this email is contained in the map, and it will give us false if the email is not contained. So now we can use that function here. Let's comment this out. So we can use that function here and say, is email taken? And we can pass in the candidate email, like maybe Jacob at yahoo.com, and of course we pass in our database of users. So pass in the users map, and is email already taken, return a boolean. So I'll just use var for that, and it will give us is taken, and you can print the result of that operation. So you can say is taken, and you can just print out the boolean value. If you have a question, just go ahead and ask. And we see that we have is taken is false, because the email address is available. If we check this with an email address that's taken, like ken@gmail, I think we already have that, we see that is taken returns true. So contains key allows you to do that. Contains value allows you to check a whole value. Might run into a bit of complications if we try to use it with full objects, but let's see. So we can also do users map dot contains value, and here I can have a user, and var is present maybe, and just drop that so that it's readable. So we can have that is present function, and we can print is present, and let's see. So present is true, because that object already exists. If we change it a bit, maybe say this becomes Mark instead of Alex, and the name is Mark, and the ID is probably 32. If we do that, we get false. So you can check by value, you can check by key. So that's some of the stuff you can do with maps. So maps are very interesting, but the most important thing you need to remember about maps is you use them when you want to do performance optimization. So if you have an algorithm like we had earlier, where we were looping over all the users, just checking every user whether they match the email, you can make that algorithm 10 times as fast by utilizing maps instead of using lists or other regular data structures. So that's the advantage of maps. There's additional capability of maps that I think we'll be able to go over. But first, let me know if there are questions. Okay, so the silence means that has been explained well. So we've looked at key set, we've looked at entry set, we've looked at a lot of the capabilities. Maybe I can also remind you that things like comparable and comparator, you can also do them with maps, because those are available for all collections. you can call collections.sort on a map, and you'll be able to pass in the sorting order. And I think that should work. The way you write it might be a little bit more complex than you will do with a list, but the functionality is essentially the same. So that's that. The other operation, and right now I'm just passing through the operation that we have because we've essentially looked at maps. So the other thing you can do is you can do remove, and remove has two variants. You can do remove by key, and you can also do remove by key and value if you want to be more specific. So we can say remove Joe at gmail.com, and after remove we can iterate over the list again, get rid of some of these printouts so that it doesn't get too cluttered. So now we can do users map dot for each and look through it, and of course here we know we pass in the key and value, key and value, and we can print those. So let me just print email for now, so that we see if Joe's email has been removed. So if we run that, we'll see that now we have Ken and Alex. So before removal we had, let me just print before removal, so you can do users map up here for each, and again K and value, key and value, and I can call print line and print the key, which is our email. So we'll see that before removal we had Ken, Joe, and Alex. After removal, we only have Ken and Alex. I should probably separate those. And in Java 5, if you're not using something, you can hide it with the underscore keyword, so that you don't have floating variables that you don't need. So this is after removal. So we'll see that after removal, we only have Ken and Alex. But before we had Joe, Ken, and Alex. So we had 3. After removing by key, we have 2. So that's how you can do remove operations. You can add a key, you can add a map into another map. So if we add a map of integers, so we have a map of an integer key and a string value. And let's say this is a map of fruits based on some value. Yeah, this is another thing that we need to cover. So when the same way we were doing Set.of and List.of, a map also allows you to have a similar implementation, except it's a little different. So you can call .of like that, but it's you can call map.of entries, and this allows you to pass in entries. Remember that entry object that we talked about up here, this object. So you can actually use those entries to initialize the map, and this allows you to create a new entry, of course map.entry, that contains our key and a value, or I believe it can figure out how to map what you're passing into an entry. So here, since we're using integers key, you can have 1, and 1 here would probably represent apple. You can have, I think I need to wrap this somehow. Wrap this into an entry. Map.entry. Hope I remember how to do this. So can I do new map.entry? Okay. It looks like I've forgotten how to do this. Joe, Kennedy, have you guys done that map.of-entries function from Java 9? I have seen it somewhere, but I've forgotten how to use it. Because essentially what we are supposed to pass in is an entry, and we can pass in multiple entries to form the map itself. but just doing new map.entry doesn't seem to work. You can just look it up. Map.of entry. Map.of entries, Java doc. But this is fairly new, so it might be understandable why it might seem a bit esoteric. So this, I don't think it's even Java 9. I think this is probably Java 21 or something. So this is fairly new, but it's a way of initializing maps the same way you do with the same way we did with set and list. So this is the Java doc for map. Yeah, so map.entry. Yeah, so there's off. We can use map.off and just pass in key value pairs, and you can pass them in this way. It looks a bit convoluted, but essentially you could do. That's why I prefer map.of entries, but we'll look into how to use that. So you can do map.off, and you can pass the value like 1, and the next thing here would be Apple. But it gets tricky when this map now has more than one value, because you have to be very careful to maintain that dance. So this would be map dot. So this would be 2. So we have the first one here is key is 1, value is Apple. Second one is key is 2, value is orange. Then we have, then we can have 3, and value is maybe mangoes. So this would work. You'd be able to initialize the map like this, and yes, go ahead.
The map of it. What are you trying to do? You can, if you go to the Java doc, where did I see it? On the, yes, on the map.html, down there's an entry. Down there. No, just Control F. Control F. And then entry bracket. Opening bracket, yeah. Yeah, that one. Yeah, it's a static method, yeah. Yes. Okay. Yeah, but if you do a static import, it becomes entry. Yes. Yep. Yeah. Right.
Thank you for that, Joe. So that's so this is another 2 ways you can initialize the map. So you can use map.of entries, and you can use map.off. So map.off is a bit crazy. There's some interesting discussions that came up when this API was introduced, because it goes like this for a while. So this is like the internal implementation of that .off function. So you can pass these values up to some degree, and you do key value pair. Not very sustainable to do this, because doing like this, it might get to a point where you might get confused or make some mistakes. Map.of entry is a bit better because now at least you're wrapping it in an object, and these objects could be coming from some other part of your API, but you can essentially do the same thing. So you can do it 3 times to represent a similar map as the one we have at the bottom, and this would be orange. This would be mango. Mango. Yeah, and these 2 maps would represent the same thing. So if we did an iteration on fn using forEach, and of course when you do that, use the key and the value. Use the key and the value, and we can print here passing in the key and the value. So this would be, so I'd concat that with the key and then the value. So the value is the fruit, the key is that random integer. And if we run that, we'll see that we get 1 apple, 2 orange, 3 mango. So it creates the map just like we did with the other method. And we get the same effect if you do it this other way, using map.of. And if we look through fruits here, just comment this, I think we should see the same effect. 3, 2, 1 apple. So yeah, so there's a lot more capability. So this is new ways you can initialize your maps. And I think, like I was saying, I think this is probably a Java 21. Yeah, Java. Yeah, so you can see, yeah, this is JDK 21. Yeah, so this is not even Java 9. So this came from 21. And that's the new capabilities that were added to maps. So just like List.of, remember this fruits map should now be unmodifiable. So if we did fruits.put and we put number 4, and number 4 is grapes, if we run it with that, we'll see that we get unsupported operation. Why? Because this fruits map is unmodifiable, because it's we used map.of, so you cannot modify it. So I wonder if of entries behave the same way. It behaves the same way. So let's say if we did fn, so here we have fn, and if we did put the 4th value, and the 4th value is again grapes, let's see if it behaves the same way. So it's also unmodifiable. So that's also unmodifiable. So if you use of map.of or map.of entries, you are creating an unmodifiable map, which means you can also create the unmodifiable map using unmodifiable collections. So you can do string unmodifiable is equals to collections dot unmodifiable map, and we can pass in fn, and this would allow you to create an unmodifiable collection. So if we did modifiable here and we try to do put, I would be able to get this unsupported operation exception. So yeah, so that's all about maps. There's additional things that I'll leave to you as exercise to the reader, or will probably might end up covering in the functional programming phase of this bootcamp, and that is compute if absent. And there's another one which is compute if present. So these ones utilize lambdas, and they'll allow you to perform operations on maps in line using lambdas. So you can do fruits.compute if absent. So you can use compute if absent if you want to insert another key, but you only want that key to be inserted if it doesn't already exist in the map, and the process of inserting that key involves some computation. So you can have so it will have the key. Let's see if I can get this right. So it will have the key that you're using, and our maps key uses an integer. So let's say we want to insert number 4, and the value we want to insert is grapes. And then we would use an operation for inserting grapes, which could be the value and then you compute the length. So something like the length of the string. So here, okay, let me see. So we pass in the key, and then we pass in the map function. Okay, so we don't need to pass the value again. So we pass in the map function, and the map function will determine what the value would be. So if so for this, it would be the number 4. That would be a new key, and the value here would be maybe grapes, which is a string. Obtain the length. Looks like I'm missing something. Let me just check the signature again. So that's the key and the mapping function. So the mapping function here receives, so it's another lambda. It's like an embedded lambda. So we have the key and value, but then we have the lambda with another key and value. Joe, can you help me here? If you're there, Joe.
Sorry?
So this computive absent, I'm supposed to pass in a key and a function. So a value, which would be the new key, and I'm supposed to pass in a mapping function. But I'm having a bit of trouble with that because I want the new value to be the string grapes.length. So the length value of this, in fact, the value should just be grapes. What could I be missing?
Oh, okay. I don't think lambdas you're supposed to, when you declare them, you're supposed to put a value. It's just a parameter.
Oh, like that?
Just put X, something like X.
Oh yeah, yeah. So that would be like the new key, right?
Yeah.
Okay, and maybe so this should do it. But I want to insert a key, which would be number 4, and then the value should be like grapes, the new value, the value that matches that new key.
Yeah. Since there are two different types, you just state it explicitly, like the way you have done for each of them.
So K, but can I still use K and V here because I'm not iterating?
I don't know whether is it explicit.
Let me look at the docs and see. So we are looking for computive absent. Oh, so this is the API.
Oh yeah, okay.
So we pass in a key, and then the second argument is a mapping function.
Okay, yeah.
So like key, K, new, I say, so this is the mapping function, and then we can call whichever other function we want to do.
Yeah.
So you get the key. Okay. Then the integer, like 4. I'm lost again.
No. This is declaration.
Yes.
So you don't put values. Yeah.
Okay. So this can't be a value. This has to be the mapping function.
Yeah.
Okay.
Okay. So why 4?
So what we want is, since we already have 1, 2, and 3, we want to use computive absent to add 4 here with the value grapes.
Oh, okay. This is an expression. So write key the way you had written, and then after the arrow down there, add another key.
Okay.
No. Sorry. How is it supposed to be? Oh, go back. Sorry, go back. After key, you put a comma.
So after key, this one.
Yes, and then K.
Okay, and then K. So this would be the integer key.
Yes.
Okay.
And then because it's not one statement, okay, put the curly brackets. What do you call them? The curly brackets
This one.
inside. Yeah, because this is more than one expression. So if k is equals to is greater than 3.
Okay. So I do an if condition here.
Inside here.
Okay.
Yeah.
So inside here we do if k is greater than.
Yeah. Put the
brackets.
The brackets first. And then is it supposed to, because the grep there is supposed to be semicolon?
Yes.
That's why it's given. Yeah, it's given a.
It's
error.
multiple statements.
Yeah.
Okay. Yeah, this is yeah. When I saw the first example when they introduced this API, I thought, oh, this is so simple to use. But I guess the example that was used made it look easier than it actually is. So so it receives a key, and then it has the, okay, this kind of makes sense because the key is the parameter we are passing, and then this is the lambda that we are using, and the lambda should compute the new value. So
okay. Yeah, I think now I get it.
Yeah.
Don't is it how do we detect the oh, because it's here a set is a set or a map, there's only a unique value. Of course, it will always iterate the 1, 2, 3, and it will always find. That's why there's no if condition. So the way you have written is it's fine. Yeah.
This, I was expecting this to work, but it's showing.
It's not.
Yeah,
It's supposed to work now.
Yeah, but it's showing red on this key variable.
What? Is that an error, really?
Because I was expecting, okay, so maybe it's expecting you to pass an explicit value, like for Sherry, it's expecting you to pass a new value. So the explicit key, so the explicit key for, and then we have this other lambda, and this lambda receives the key and the value. So in case you wanted to use the key for computation, so let's say we wanted to prefix the final name with the length of the okay, sorry, so no, I don't get what's happening because I'm passing key twice. So 4 is the key, and then k here. What's up with this new k? Okay, let me just concat that new k to this final string. See what happens. Yeah. So in short, what we are trying to do is insert this key 4 if it doesn't already exist in the map. We'll do like a safe insertion. And now if we iterate over that, do for each, of course, k, v, and then we, of course, we print it, io.println, and we are printing the key which should be the integer, and then we are printing the value which should be the string. So now to see whether this grapes was added, unsupported, this must be somewhere else. Where? Compute if absent. Oh, okay, I'm doing compute if absent on an unmodifiable map. So I'll need to use a modifiable map to demonstrate this. Well, just made my work really extra. Map, integer. So we've essentially done what we are supposed to cover in maps. So consider this an exploration of the new features in maps. So this is modifiable fruits is equals to new hash map. And in modifiable fruits, we can put some fruits. So 1 and apple. And then let's have the 3. So we have 2, we have 3. So there's apple, there's orange, there's mango. And since that's modifiable, we can use it on this compute if absent, and we can print that. So it will attempt to insert a new key into this. Let me get a bit closer. So what this will do is it will attempt to insert a new key, which is 4, into this map if that key doesn't already exist. It's like a safe insertion. And then here I'm just printing out if the value was inserted or not. Comment out here.
It's interesting.
Yeah, I saw it on Stuart Mark's talk on collections refueled, the updated talk. So I talked about this compute if present, compute if absent. So you'll see now we have 1 apple, 2 orange, 3 mango, 4 grapes, and then it has that prefix that we added, 4.
Yeah, it's like a lazy value.
Exactly. So now, in fact, we might not even need to use it there. And since we're in Java 25, we can, Java 25, so Java 25 onwards, you can silence things that you're not using. So if we try to add a key that already exists, let's say key 1, so we already have key 1 and you want to change it to pairs. Pairs, how do you write pairs? Pairs the fruit. Okay, let's assume that's how you read it. So we are inserting 1 and we are adding pairs at index 1, but index 1 already exists. So with a regular map, this index 1 would be replaced with pairs, but compute if absent should detect that value already, that key already contains a value, and at least my expectation is that it should skip that key and not modify it. Yeah, so you see it's maintained. So 1 is not changed. Going back to compute if absent. So 1 is not changed to pairs. 1 is now apple still as it was. With the regular put, if I did a regular put on this, mf.put, and I put with the key that, and I put pairs, and let me comment out this modify if absent. If I run it, you'll see it mutates, it modifies the map. But with compute if absent, it's careful. It's like I'm going to change the value only if that key doesn't exist. If that key exists, it backs off and doesn't change the value. So it's a good way if for modifying your map collections in a more predictable manner. So that if you are accidentally changing the value of a key that already exists, the language is able to help you by not changing it. It has a cousin which is compute if absent, compute if present. So there is compute if present, which works kind of the same way. So you can pass in a key. So the difference between compute if absent and compute if present is this compute if absent will change the value if the key does not exist. Compute if present will change the value only if the key exists. So if we do 5 here and we don't care about the key, and we want to add, this should be 5, 5, and we want to add another fruit, which is, wait, this one is different. Okay, so the fruit we want to add is banana. So compute if present doesn't work with the same lambda, so it doesn't receive a regular mapping function. It works with the by function. So with the by function, this is a bit different. Do you have any experience with by functions?
Oh, by functions. Yeah.
Can you help us complete this puzzle? Because I was expecting that it would work with a regular mapping function, but it doesn't.
I think by functions has 2 parameters inside.
Yeah, so it's like we're supposed to pass in like a second parameter here.
Oh, you put brackets.
Oh, okay. Oh, yeah.
And then you can even use bar if you want. Yeah.
Like that, eh?
Yeah.
Okay. So what we want to do is let's look at this doc a bit. So it receives a by function, and what this is supposed to help us achieve is if the value for the specified key is present and null, attempts to compute a new mapping given the key attempts to compute a new mapping given the key and its current mapped value. So if the remapping function returns null, the mapping is removed. So so just coming back to this, so what we expect from compute if present is that it will change the value if the key exists. If the key doesn't exist, it won't attempt to change the value. So let's just see that in action. And yeah, so here I'm just printing again after we do compute if present. And you can see, so since we're using a key that doesn't exist, we're using 5. Banana is not added. So let's try using a key that, using too many printouts here. Let me kill this one. So we have pairs, orange, mango. So we don't have 5 because that key doesn't exist. Now, if we use a key that exists, like 2, let's see. So if we use 2, you'll see that 2 is now replaced with banana. So compute if absent allows you to modify the map only if the key that you're passing, the new key that you're passing doesn't already exist. Compute if present allows you to modify the map only if the new key that you're passing already exists. So this would be good as a replacement for what we saw with the list in. So when we were doing what is that? When we're doing a list.set. So this is like a close cousin to that operation, where you go to that particular index, and instead of just adding a new element, you swap out the value. So index 0 now has a different value. So the same with this, you go to that key and you swap out the values. And it won't try to append a new value if that key doesn't already exist on the map. So same way, if you are, I think with the list, probably they might be different. If you call set on an index that doesn't exist, the list might accommodate you and append a new value at a separate index or something else. But with maps, just know that compute if present allows you to do that conditional insertion. So now that we've gone to like the edges of maps, I think I can safely say we've covered maps exhaustively. There's nothing we've left until, I mean, we've even looked at features that are as recent as Java 21. I don't know if the collections framework has been modified more with the like 25 and so on, but I think major changes like this came in 21. 9 came with those static functions, List.of, Set.of, map.of entries, map.of, like that. And of course, 8 brought us forEach function and the use of lambdas. And 7 had the iterator. So I think we've covered the Java collections framework exhaustively. And so if I'm missing something, because this is the last session on Java collections, if I'm missing anything on collections that you might want the rest of the community to know about, this is your chance.
There's a
Yes?
Yeah, there's a preview feature in 26 called of lazy.
Oh.
Yeah.
Of lazy.
Yes. For both mapping and list.
Okay. Is it added to the general collections API, or it's specific to map and list?
It's based on the new lazy constant. Go to the docs. Oh yeah.
Oh, lazy constants. Yeah, okay.
So you can develop immutable map or lists later, but not during initialization.
So it's immutable later.
Yes.
You initialize it empty, and then when you add values, it becomes immutable.
Yeah, after that.
That's okay. That's very interesting. So you get lazy constant dot off, and then you pass in a lambda. I think this is to compute the values.
Yes. But now, the map and the list, they decided to, because there's no point of creating map list separately, yet we have an API for that. So why not add the methods in the map itself and the list itself?
Okay. So now it,
Yeah, so I think if you scroll down, you'll see it. Here's just the introduction of the
lazy list. Yeah.
yeah.
So yeah, we have a
So
list.
Then of lazy. Yeah. The idea is because maybe the new orders are expensive,
Of course.
and sometimes this delays your application startup. I think people who do Spring experience slow startups.
Oh, well, of course. The startup is a major problem. I've seen talks about it.
Yes, so that's the idea.
Okay.
Why make something expensive that is immutable to be initialized later? Yeah.
Okay.
And then in future it will be a keyword, probably.
Yeah. And I think this goes into aspects of multi-threading as well.
Yes. And this new orders is just not initializing. It can call a method inside also.
Yeah. I'm seeing you can have like so this is just you can have a lambda, and these new orders can be like a function, some other service function that you call to compute the orders, right?
Yeah.
Oh, interesting.
Even map.
The way it behaves, I think it depends a lot on some multi-threading things.
Oh yeah.
Looking at just the behavior, and Kennedy's here. Kennedy will be showing us concurrency later on. So Kennedy, I hope you'll cover this when you do concurrency.
Question actually.
Yes.
This lazy constants, I haven't looked at it. Actually, nimesikia sahi. Nini Joe, can supplier achieve whatever this lazy constant doing? Because I think, okay, is there some similarity by far?
Not really. For example, you cannot do static final on a variable which the JVM can identify that this can be optimized. If you can initialize something later which is static final, it means the state itself inside. Maybe there's a variable that is not mutable. There's a variable inside that is mutable, so the JVM might not optimize it. So it's good to, even if you go, I wish the way Sam was showing, when he was saying map off, and then he goes back into the detailed immutable class. I don't know whether it was showing the actual source code. I don't know. There's a way you are clicking, and then and then you are going. This is the source code complete. Yeah, I wish you could see the source code of these immutable collections inside. Yes. You see this one at stable. This is lazy constant, kabisa. You see its final int size, but it hasn't been initialized properly. Maybe in the constructor. This is just to tell the JVM, just think that this won't be modified anywhere. So optimize it. That's the idea in general. Yeah. So I think Kennedy, in short, it's just optimization. One is optimized, the other one is not optimized. Yeah, but this one they have been using it internally in the JVM. So, but as users, we haven't been able to access this feature for a very long time. So they want to now introduce it as a proper API, which is lazy constants. Yeah.
So this stable, Nikki, the size, if I know in size, if I initialize it once, Nivo,
Nivyo. Yeah, Nivyo too. Yeah.
Okay.
And then JVM it notice kumbe it's under lazy constant or at stable, and then it decide there's no point of being cautious. Let me optimize the code kabisa. Like what I showed you in my previous presentation, whereby the JVM was removing the methods, mpaka tukabaki na a value. That's what it's doing actually. Yeah.
Yeah, that's interesting. I think I'll do some research. Maybe
Yeah.
for your concurrency stuff, I can mention something na nikishindwa, I hope will be there.
Ukitaka proof, fanya benchmark speed. Just do a benchmark speed, uta notice difference. Yeah.
Yeah, okay, I'll try. See what's up.
Okay. Yeah.
Awesome. So we are looking forward to that. That should be soon now that we are done with Java collections. And next we'll be having somebody, actually 2 people from the organizing team to cover algorithm optimization. So that should be interesting. I don't think any of them is on the meeting today. I don't know if Ian is here. Okay, the probably is not there. So yeah, so they'll be covering space efficiency and the other concepts in optimization, and then from there we'll proceed to the next topic. So for everybody who has been there since we started this Java collection series, congratulations! You should now be receiving your certificate soon. Going through the Java collections framework. And that marks the end of Java collections. I'd encourage you to look into some talks by Stuart Marks. He does this series called Collections Refilled. Stuart Marks, Collections Refueled. So he's done, anytime there's a change to Java collections, he goes ahead and does a talk. In fact, there's even a podcast in JavaCast. Yeah. So look at his previous close to 10 years of collections refueled talks, and you'll be able to see how these components change within the language and how you can take advantage of new capabilities. Otherwise, this has been super stretched. We're almost 2 hours in, so I'll end it there. And thank you to everyone who joined us, and see you on the next Java for Everyone, which will be next week. So see you next week. Yes, Joe?
I don't know whether it's okay. I can explain something else.
Oh, for sure. Go ahead.
Yeah. So kuna hii criticism of Java that the list collection, there's no way the collection and the list, the maps, etc. There's no way you can say this is mutable and this is immutable. So many languages they tried to introduce, I think, immutable map, immutable list. I think Kotlin also did that. C# also tried to do that. etc. So I saw a very interesting JDK conversation that Java alianza hivyo, but later on they realized hatuna mutable na immutable arrays because every collection is behind the scene is just an array, like what Sam you were saying. Backup ni array too. So they discovered later on that arrays are not immutable, they're always mutable. That's why when you are you are trying to initialize an array, maybe using generics, let's say a list and then maybe string, you can map it to a list object, sindio? The list. But you can, if you try to add a value to that list object, it always throws an exception. Yeah, but at compile time, you can never detect such a issue. Yeah, so it's usually a runtime, whatever problem, not a compile time problem. The reason is that arrays in Java are not immutable in nature, and they're always mutable, so kuna kuanga na issues of some specific rules. So the reason why they took that approach is because if they decided to introduce immutable arrays, mutable list, mutable map, kutakuwa na a lot of API whatever explosion. That was the reason. And then if a library made a mistake whereby pengine ilitengeneza functions that accept mutable arrays, for you to actually make them immutable, it complicates also your code. I don't know whether mmencounter hizo vitu kwa mkitumia Kotlin ama Scala ama yeah. So they decided to make one API, a collection or a list, and then the subclasses. That's why the collection library ya Java inakuanga ndogo sana. Yeah. So they are trying to rectify hizo rules. So they are trying to introduce immutable arrays so that we can detect such kind of complexity. Like hapa huwezi jua whether this list is an if I passed this end list somewhere in another function, there's no way your IDE will tell you this is immutable or not. So when you say end list that add, I think is it end list? Yes. Try to add say end list. I think sijuka NetBeans itakuwa smart enough to detect. Just yes. Yeah, that's that's a runtime exception. But if they introduce immutable arrays, just go to the Java talk ilitokea tu juzi. They are planning to introduce that whereby it's new final int and then hivyo. So hiyo final inamaanisha this array is immutable. So if you in future if they introduce such a feature, the IDEs will be able now to detect this as a array as a compile time exception in advance. You see, yeah. So it'll take time nielewe hivyo, alafu ndio click. Oh yeah. So that's the idea. Yeah, and they won't change anything. The code won't change. Yeah.
Unpredictable behavior. So the good thing with Java is the backwards compatibility is really stable, and when they add anything new or they change anything in the language, it's changed in a way that doesn't break existing functionality, but also enhances it, actually. A good example is how we saw the relationship between an unmodifiable list and a regular array list. So you can do arrays.as list, and you can use that arrays.as list to create an unmodifiable list, and then that unmodifiable list won't be modifiable, but the array list that you created, once it's modified, it updates the unmodifiable list. So it's a really nice relationship.
And please go just investigate how other languages are doing.
Yeah.
You'll be surprised how such a simple concept is very complicated too.
Yeah, I mean, Kotlin is a perfect example. It's a mess, the way they use this mutable list, immutable list, and when you're initializing them, you have to like declare them like that, and it's a lot of it creates a lot of syntax sugar, kind of the same problem that C++ is dealing with, where when you add something to the language, you have to introduce new syntax and make doing regular programming, day-to-day programming more complicated. So I like like how Java is doing it.
Yeah, it's very interesting actually. Designing program languages is difficult. I've come to realize. Yeah.
And the guys at Oracle are doing a great job. So yeah.
Very interesting. Yeah. So thank you.
Oh, awesome. Thanks for that, Joe. So tomorrow we have Java by example, and we will be. I'm still trying to figure out what we'll do tomorrow. So when you guys come in, I'll let you guys know. But I can send a message in the group telling you what we managed to decide to do. But the show will be on. So come, we have some interesting technical discussions, and we do some practical engineering work. Otherwise, I think I've kept you guys here long enough. So let me wish you guys a wonderful night, and see you guys tomorrow. And for Java for everyone, see you guys on Tuesday for the next series. I don't know if I'll be the one teaching, so I don't know. I'll check the schedule. Maybe it's somebody else. So kwaherini.